The topic that I am about to explain right now is all about microprocessor system, and these are the topics that to be tackled and designated to me to report. These are the following: memory reference instructions, 4 types of addressing mode, which particularly the indirect and direct addressing mode, the register direct and register indirect mode, and on-chip register addressing, and last, conditional jump instruction. Before we begin to the topic about memory reference instructions, I would like to tackle first the basic computer instruction that has 3 types, which are memory reference instructions, register instructions, input-output instructions. Today, we are only focused on the topic memory reference instructions. This is important in order for us to understand in context of basic computer organization memory reference instructions. Because memory reference instructions are the instruction which help us analyze how the data from the memory is actually being fetched and being executed. As shown in this page, shows those other formats other than memory reference instructions format for you to recognize their differences as types of instructions that being used to a basic computer. These 3 image below in each definition is the exact format of its type of instructions. This is how we could determine that any particular instruction is falling under the category of memory reference instructions. So let us read memory reference instruction. Uses 12 bits to specify the operand, address 1 bit for indirect address. 0 to 11 holds the address, and 12 to 14, which are the 12, 13, 14, holds the opcode, as you see the pic below the definition of memory reference instructions, and 15 last, which is represented with I, whereas if I is equals to 0, it indicates that it is a directed addressing, while if I is equals to 1, it indicates that it is indirect addressing. So, the opcode of memory reference instruction should be in the range from 00 to 110. I'll just read the definition of the other instructions, and here they are. The register reference instructions are recognized by opcode 111 with 0 in leftmost bit, which is 15-bit of the instruction. The 12 bits are used to specify the operation done with AC register. As you see, the 12 bits they are pertaining is 0 to 11 bits, which holds the register operation, and 12, 13, 14, 15, or the remaining bits out of 15 bits holds the number of 0, 1, 1, 1, and its opcode should be equal into 111, wherein its I should be equal to 0. It's unsimilar to the opcode of the memory reference instructions because the opcode of the memory reference instruction should be in the range between in 00 and 110. Next, input-output instruction is recognized by opcode 111 and with 1 in bit 15. It's lookalikes in the register reference instruction, but they are different. The value of I. We can see that the 12 bits they are pertaining is from 0 to 11. It holds the input-output operation, while the 12, 13, 14, 15 it holds the value the 1, 1, 1, 1, and its opcode it should be equal to 111, where its I or I should be the value in equals to 1. Next, we are here in our main focus, which are memory reference instructions. In memory reference instructions, first 12 bits 0 to 11 specify an address. So as I explained kanina, yun nga, from 0 to 11, yun yung 12 bits na tinutukoy, yun na nag-hold sa address sa memory reference instruction. Ang pinagkaiba lang nilang tatlo is, pag sa memory, yung 12 bits na 0 to 11, it holds an address, while sa register, it holds the register operation, while the input-output, it holds the input-output operation. Yun po. And the address field is denoted by 3x in hexadecimal notation and is equivalent to 12-bit address. So yun po yung address field ng memory reference instruction. Makikita natin sa table na papakita natin kanina kasi if I is equals to 0, from 0 to 6, yun yung nakalagay. And makikita natin yung tinutukoy na 3x, which is in hexadecimal notation. The last mode of bit of the instruction represented by symbol I. Yun nga po yung pang 16-bit, which is the number 15 na nag-holds naman or naka-represent as letter I. Whereas yung nga sinabi ko, when I is equals to 0, the last 4 bits of an instruction have a hexadecimal digit equivalent from 0 to 6. Since the last bit is 0, When I is equals to 1, the last 4 bits of instruction have a hexadecimal digit equivalent from A to E since the last bit is 1. So makikita po natin yung sinasabi niyan sa next page. Tapos yung 3x yung sinasabi is makikita natin yan in a hexadecimal code. So ito po yung 7 memory reference instruction. Ito yung A and D, ADD, LDA, STIN, BUN, BSA, and ISC. Yung sinasabi po din is, if I is equals to 0 dito, the last 4 bits of instruction have a hexadecimal digit equivalent from 0 to 6 since the last bit is 0. So yung makikita mo ito, 0xxx, 1xxx, 2xxx, and so on hanggang po sa makapag 6. And dito naman po, if I is equals to 1, the last 4 bit of instruction have a hexadecimal digits equivalent from 8 to E since the last bit is 1. So ayun nga po, 8, 9, A, B, C, D, E. So I will read the description of every memory reference instructions symbol. So A, which means end memory word to accumulator, and add memory word to accumulator. LDA, which is load memory word to accumulator. STA, which means store content of AC in memory, and BUN, which is branch unconditionally, and BSA is branch and save return address. ISC is the incremented and skip if 0. So these are all the operations that done refer to the memory reference instructions.